So last time we talked about the central limit theorem use its strength and properties to functionally see other tools in statistics that would evaluate a certain data, so specifically inferential. What we learned from last time is the central limit theorem allows us to turn any distribution, no matter how weird it is, normal distribution. But take note that the normal distribution that you produce is called the sampling distribution of the means. Alright, so just remember that it is of the means, just not sampling distribution. And what we learn from this is that the mean of the population and the mean of the sampling means, of the mean of the means of the sample, is just equal. And we also learned that the standard deviation from the population can be used, or we can actually interchangeably approximate it by using the standard deviation of the sampling means. In that case, the standard deviation of the sampling means is equal to the standard deviation of the population all over the square root of n, where n is the number of samples. Remember that the number of samples is very different from the sample size. Just make sure that's very clear for us. Alright, now in terms of hypothesis testing, we always wanted to assign something called a null hypothesis and a alternative hypothesis. Now it's up to you how you call it, maybe HA or HB, doesn't really matter. So in this case, you have null hypothesis. Null hypothesis normally is there is no effect, or basically you are particularly saying that a certain event or a certain factor wouldn't have any effect on a certain statistic of a population. But statistically, what it means is the mean of the population would be unchanging, it wouldn't change. But so unchanged. And in terms of the alternative hypothesis, it seems to be that a certain factor would deliver a change. Mu changes. Or alternatively, you can say that the mu that we obtained wasn't the mu of the original population. It's different.